The subject of this short talk is facial composite construction, a facial identification tool used in police investigations. We've been working in this area since the late 1990s and have since commercialised our research. Our facial composite software is now used by the majority of UK police and also in many other countries. So what is a facial composite system? A facial composite system is a tool for creating a likeness to a suspect's face based on an eyewitness's description. This likeness might be used by the police internally or might be released to the general public in an attempt to locate the suspect. The term facial composite has become synonymous with brands such as PhotoFIT, Identikit and EFIT, electronic facial identification technique. The standard approach to constructing a likeness to the suspect has been to piece together individual facial features. In this photograph we see a witness working with a police officer using the PhotoFIT system, which was introduced into the UK in 1970. The witness selects facial features from a card catalogue. The operator then arranges those facial features in a glass frame. The operator might also add artistic enhancements to the composite, such as a beard, and he would do this by drawing on the glass frame with a Chinograph pencil. The PhotoFIT system was used up to about 1990 in the UK, was then superseded by an electronic feature-based system in which the facial features were stored in computer databases rather than in card catalogues. Now, unfortunately, there are some problems associated with this feature-based approach. It turns out that witnesses are really rather poor at describing individual facial features and recalling those descriptions from memory. In addition, psychological studies have shown that we recognise faces as a whole or holistically, and not simply as the sum of individual facial features. On this slide we have the internal facial features of 6 famous people, and yet identifying those famous people from their facial features shown in isolation is really quite a challenging task. If you are unable to determine these people from this slide, from their internal facial features, then let me enlighten you. All right, so it is in fact the 6 actors to have played James Bond. So given that witnesses are rather poor at this feature-based approach to composite construction, we felt that it was time for a different method. So we developed a new system called EFIT-V. In fact, the latest version is called EFIT6. And this system is now used by the majority of police in the UK and also by police services in many other countries. Importantly, this system is based on whole face recognition and is not based on the witness's ability to recall facial features from memory. So how does it work? We build a model of facial appearance which is capable of synthesizing realistic faces. Using this model, any face can be approximated by a set of numbers. Since we don't know the set of numbers that corresponds to the suspect's face in advance, we must search for these iteratively or step by step using an evolutionary algorithm. So the idea is a little bit like biological evolution, in which we have a string of numbers which is the genotype, and the corresponding face image can be thought of as the phenotype. So in theory this is how it works. We generate 9 faces from the model, and the witness selects the face which is closest in appearance to the suspect. We then take the genotype corresponding to that face and replicate it 9 times. And then we choose some of the numbers at random from the genotypes and change their values slightly. This results in a new set of 9 faces. Then the idea here is that 1 or maybe more of the faces in the new set of 9 is closer in appearance to the suspect than the face that was previously selected by the witness. And repeating this process a number of times of selection, replication, mutation, we step by step get closer in appearance to the suspect's face. Let's have a look and see how this works in practice. This is the EFIT-6 facial composite software, and I've skipped a number of steps to get to this point. And here what we're doing is asking the witness to look at the 9 faces and select the one which is closest in appearance to the suspect. Once the witness has made a selection, we click on View Next Group. Okay, and what we're doing here is taking the face that was selected by the witness, replicating the genotype, and then making mutations on those genotypes to produce a new set of 9 faces. And then the witness repeats the process. So again, they look at the 9 images and select the one which is closest in appearance to the suspect. By repeating this process a number of times, we gradually get closer and closer to the face which is in the witness's mind. In other words, the likeness of the suspect in the police investigation. Now we can do other things as well. We can do all the things that you'd expect to be able to do in a facial composite system. We can add hair and clothing. Okay, and in this system there are actually thousands of hairstyles and clothing items to choose from. So this is a very short demonstration. In practice, it would take probably an hour or longer to build an acceptable likeness to the suspect. Okay, so I need to say something about image accuracy. On this slide, we have a portrait composite image. So in other words, the face on the right-hand side of the screen has been constructed with the operator looking at the subject during the construction process. So this scenario is not forensically relevant, of course, unless the witness has a photographic memory. And we all know that witnesses have imperfect memories, and that memory is going to deteriorate with time. In this slide, however, we have composites constructed in real cases. So for each pair of images, the face on the left-hand side is the composite image, and the face on the right-hand side is the corresponding custody image. Now I'd like to conclude by just saying a few words about the possible future of facial composite construction. It might be that we can obtain a more accurate likeness of the suspect by using an alternative method for tapping into the witness's memory. One way in which we might achieve this is by displaying facial stimuli to the witness and then recording their brain activity. So at the moment this is science fiction, but who knows, maybe in a few years' time this is how we'll be constructing composite images. I'd like to thank you for listening, and if you want to know any more about facial composite construction, then I urge you to visit our website, or alternatively you can contact me directly on the email address here on the screen. Thank you very much.